Hello and welcome. In this video we're gonna take another step and learn how to control the infrared, not the infrared, but ultrasonic distance sensor. The infrared remote is gonna be a subject of one of the future videos. The ultrasonic sensor, which comes with starter robot kit and other kits, which is located right here, allows us to know the distance from an obstacle that our robot is facing. It has to be essentially straight on facing, so if it comes at an angle, then the ultrasonic beam that comes out of one of these cylinders and is sensed in the other is not going to bounce exactly right and give us the accurate reading. So that's a small limitation. Let's go ahead and get started. We're going to start our Makeblock software. We're going to start a new program. We're going to go ahead and connect to our robot. And finally, we're going to switch to Arduino mode so we only see relevant things. We're going to start by starting the new Orion program. And we're going to set the motor speed. And also we're gonna wait a little while so we can get our hands away from the robot after turning it on. In this case, we're going to go ahead and just set the speed to 100 on both motors so our robot will start going forward. Now we want it to stop. In order to stop, we need to know the distance from an obstacle. We're gonna make a new variable and we're gonna call it distance from obstacle, and I use this what's called a camel case, where first word of the variable starts with a small letter and each subsequent word with a capital letter. Now we're gonna learn a new way to set the variables, and we're gonna set the variable from a sensor. So I'm going to, from data and blocks, drag set variable. I only have one variable here, distance from obstacle. And now switch to robot. Amongst all the actions available for various sensors and displays and motors that come with the robot, we want the ultrasonic sensor. By default, it's connected to port 3. You can actually chase the wire in your robot from the picture that I showed you, which is right here, to see where it's plugged into the board. It should plug in on port 3. If yours is plugged into a different port, you would have to change that. And I'm going to start dragging the ultrasonic sensor, and you can see how my 0, which is the block that follows word 2, changes. And when it changes, I'm going to let go of my mouse. So what do I read here? What it says is set distance from obstacle to ultrasonic sensor port 3 distance. However, it's only going to do this once at that moment in time. After that, it's not going to do it. What we need is continuously get this reading as our robot runs. And now we get to learn a new block. From control blocks, we're going to drag this block forever block in here. And then we're going to drag our sensor into it. So as I start dragging, as you see, both get unplugged. Now I can still drag forever to be underneath the speed setting, and then I'm going to drag distance inside forever. What that means, that until cows come home, essentially, what I'm gonna do is get a reading from my ultrasonic sensor, set my variable to that reading, and then continue to my for loop. I only do one thing here so far. So now we're gonna learn one more thing: how to combine multiple numbers by performing arithmetic operations. we're gonna add another variable called inches. Actually, let's do it differently. Centimeters per inch. The ultrasonic sensor emits the data in centimeters. They're roughly 2.5 centimeters per inch. I want to code in inches. So we're gonna go ahead and start by setting our centimeters per inch variable to 2.5. 2.5 would be 2.5. We use the decimal notation. Now, distance from obstacle is in centimeters, and we know there are 2.5 centimeters per inch. Say our goal is to stop when we are 4 inches from the wall. 4 times 2.5 is 10, but let's go ahead and learn one more thing. Under control, we're going to learn the if statement. If essentially is a condition. Condition goes here, and what we wanted to say is if some distance from obstacle times centimeters per inch is less than 4. Under operators, we need to drag another operator which is less than then. And we're gonna go ahead and drag it into our conditional. Now we need to say if my distance from obstacle, switch back to data blocks, find distance from obstacle. However, we need to multiply it times 2.5. So that's not gonna work quite right. What we need to do is go back to operator and find multiplication, which is right here. It's a asterisk, and drag it here. Now, back to data blocks, and we need to multiply centimeters per inch, drag it into the first circle, and times distance from obstacle, drag it into second circle, and it needs to be less than 4. The way I read it, if my centimeters per inch, 2.5, times distance from obstacle, which is my ultrasonic sensor distance in centimeters, multiplies 2, I get the distance from obstacle in inches, less than 4. Now I want to stop. If you remember from previous time, in order to stop, I need to set the speed of both motors to 0. And I'm going to repeat this forever. I could repeat like certain number of times or repeat until certain condition is true. But in this case, we're going to do it simply. So what's going to happen is that ideally, if everything works, as soon as my motor is close to the wall, as soon as my robot is close to the wall, it will stop. But if I pick it up and turn it to where there is more distance to the wall, it won't keep going because there is no other condition here that I have, and once the speed is set to 0, nothing is going to set that speed to any other value. So if I wanted to go again, I have to turn the robot on and off and then back on, so my program would start one more time. But we're not going to do it in this lesson. In this lesson, we're going to stop right here. So if you recall, we can always save projects. And the reason we do that is so that we don't forget what we're doing. And this is going to be our video 4. And I'm going to give it the name video 4 SB2. Now, let me go ahead and click on this upload to Arduino. And it's going to take a minute for my program to compile, which means to get translated into the language, programming language that the robot understands, and then be sent to my robot subsequently. And so I'm gonna give it a second. It's making progress. Now you see it's gonna briefly flash blue on my robot. Now it's gonna say upload finished. I'm gonna click close, unplug my robot, and I'm gonna face it I'm gonna set it on the floor facing the wall, and if everything worked right, it will go for a while and then stop. And it didn't stop. So I made a mistake. Let's see if we can fix it. So I made a logic mistake. So if we read this, what I'm saying is, if I multiply distance in centimeters times centimeters per inch, this is really not quite distance in inches. Instead, what I need to do is divide them to get the distance in inches. So let's fix that. I'm going to drag this out, multiplication. Instead, I'm going to operators and get the division. And I'm going to divide distance from obstacles divided by centimeters per inch. Now I have some leftover operators. I'm going to right click on them and delete them. And first of all, I'm going to save it. So now let's do an example. Say my distance from obstacle is 10 centimeters. Divide by 2.5. That's roughly 4 inches. Now that looks better. Let's go ahead and reconnect and the upload. And this kind of demonstrates the basics of debugging. As often happens, first time you try to program something, robot or really anything else, your program doesn't really work as expected. And the way you figure it out typically is talk your way through the program. So you read the code, and I do it sometimes out loud and see if it sounds right. And sometimes it sounds right but doesn't work quite right. So for arithmetic computations, I just do them in my head by picking like a random number. In this case, I picked 10 centimeters as my distance, and I know if I multiplied it times and a half, that's way far from the wall, not what I really want. So let's give it one more try. I'm gonna put it on the floor at least a couple of feet from the wall and then turn it on, and you can hear it run. And now it stopped roughly 4 inches from the wall. It takes it a fraction of the second to stop, so it's a little bit closer. Good deal. So I think we're going to stop this lesson here. We'll learn a couple of new things. We learned under operators some arithmetic operators. We used the divide, and accidentally we used multiply. We also used conditionals from here, lesser than conditional, which is the left facing angle bracket. If you want to do greater than, that's the right facing angle bracket. And the equal sign, that's the equal sign. We use the forever operator, which is sometimes called a loop, because you do something over and over again as if you're stuck in a loop. We used the set to we use the set of our variable to a reading from a sensor. We have to remember that when we do that, we have to do it in a loop. Otherwise, we're only going to get one reading and we'll never test the sensor again. And as a reminder, we remember how to stop the motors. All right, guys. Now that you've seen that, try to do the same thing yourself. And I'll see you in the next video.